Chapter 2.2, Circles. The only difference in one circle and any other circle, other than its location, is its radius. Therefore, in order to graph a circle on a rectangular coordinate system, all we need to know about a circle is its center, which gives us the location, and its radius. This is the center radius form of a circle, where HK is the center of the circle and R is the radius. Notice if the center is 0, 0, then the equation is simply x squared plus y squared equals r squared. This is the Pythagorean theorem. So hopefully maybe that'll help us remember the center radius form of a circle. Let's look at for just a minute why it's the Pythagorean theorem. So let's try to draw a circle down here. On my graph, and here's the radius, right? Well, notice that the radius is simply, if I'm talking about on a coordinate system, I can, let's change colors here to make it a little more obvious, I can fill in a right triangle using that radius, where this is the distance of my x values, between my x values, and this is the distance between my y values. Notice it makes a right triangle. So again, if I can remember the Pythagorean theorem, which we should already know, a squared plus b squared equals c squared, then I also know the form for the center radius of a circle. And this is just the same circle, except it's been translated, right? Slid up and over, back and forth. So if we were given the circle with this equation, I can tell immediately that my center is -3, 4. Now, why -3, you might ask? Because pay attention to the formula for the circle. It has a minus in it. If our equation has a plus, that must mean it was x minus -3 to put it in the exact format that I need for my center radius form, meaning h, or the x-coordinate of my center, is at -3. This piece already has the minus, so 4 must be k. So if my center is at -3, 4, I'm going to go over here and I'm going to place a mark. I'm going to put an X because that's not really on my circle. I don't want to put a point or a dot. Right? I want to distinguish that that's not a part of my circle that I'm going to draw, but it is the center of the circle. And the formula says r squared. So this can be written as 6 squared. The radius must be 6, meaning that I can go 6 units in any direction from this point. I can't go diagonally because the distance across this diagonal is not 1, right? Again, think about the Pythagorean theorem. That would be a squared plus b squared. So this is square root of 2, right? This distance here, 1.4, not 1. But each of these units between here represent 1 or up. So I could go 1, 2, 3, 4, 5, 6. There's a point on my circle. 1, 2, 3, 4, 5, 6. There's a point on my circle. 1, 2, 3, 4, 5, 6. A point on my circle. And 1, 2, 3, 4, 5, 6. A point on my circle. And that should give me enough information to be able to draw in my circle, right? And I'm not a great artist, particularly on this device, so please bear with my drawings, and I'll do the same with yours on the exams. Okay, so if I have my equation in the center radius form, very easy to graph that circle. However, the general form and maybe most common form of a circle looks like this, where those binomials have been multiplied out. In other words, here's one with numerical values in it, right? With this form, we can't immediately see the center and radius. However, if we recall from the quadratic equation information, we can complete the square to obtain, in this case, a couple of perfect square trinomials. We may need to tweak those steps just a bit to accommodate the circle situation. But here are our basic steps for obtaining the center radius form of a circle, and they're based on completing the square. So remember, the first step in completing a square was move the constant to the left-hand side of the equal sign. So I'm going to move this constant. Oh, as I do that, I'm going to go ahead and you might want to make yourself a note here. As I rewrite it, I'm going to go ahead and group my x terms and my y terms. I'm going to leave a space in here because I know I'm about to add a value, and I'm going to leave a space here. The second step is make the leading coefficient 1. In this case, it's already 1. We'll look at how to do that when it's not a 1 in just a minute. Then I'm going to take half of the linear terms. In this case, we've got two values we're trying to take to complete the square on, so I've got to do it twice. So let's do the x's first. Okay, half of that 4 is 2. I'm going to square that and add it to both sides. Now that makes this a perfect square trinomial that I know how it factors. Recall that it's going to use this sign and that first value I had, all squared. Now I've got a plus sign there. I'm just going to repeat the steps to complete the square for my y values. So if I take half of 12, that's 6, and squaring it gives me 36. So I'm going to add 36 to both sides because that makes this the perfect square trinomial that uses this sign and this first value, the half of 12. Then I have an equal. Add these together to get 36, and I have just put this standard form or general form, either one, in center radius form so that I can tell immediately that my center is at 2, -6, and my radius is 6, square root of 36. So I can come over here and easily graph that. 2, -6 is the center. And again, if I go 6 units in either direction, I'm going to run off of my graph here. So let's change our scale, right, to go maybe by 2s. Remember, if you change your scale, you must label it. You must label your scale. I'm going to use a different color here so it doesn't blend in with. So if I'm going to change my scale, I've got to label those axes. Okay. All right, so my center is at 2, -6. And if it has a diameter, a radius, excuse me, of 6, don't forget that this is 2, 4, 6, 2, 4, 6, 2, 4, 6, 2, 4, 6, and then I can draw in my circle through those points that are on my circle. Okay, let's try that again. First step is I'm going to move the constant to the other side of the equation, and as I do that I'm going to group my x terms and my y terms together, leaving a space in there for the values I'm going to add that complete the square on each one. Oh, this one's already on the other side. Already on the other side. Pay attention to what I'm doing. All right. And now make the leading coefficient 1. This leading coefficient is not 1, so to make it 1, I'm going to divide everything by 9. All the way across. That must be your second step. Must be your second step. Notice that's going to change these values. I can't begin completing the square until I have the correct value here. I'm not going to take half of 6. So that leaves me x squared minus 6/9 is 2/3 x, and then plus y plus 2/3 y equals 23/9. Then I'm going to take half of my linear term, so half of 2/3, of course, is 1/3, and 1/3 squared is 1/9. So I'm going to add that value to both sides, and then do it again for the y's. Oh, it's the same number. Half of 2/3 is 1/3, and 1/3 squared is 1/9. So I'm going to add 1/9 again to both sides. Okay, I did that because that makes this a perfect square trinomial that factors with this sign and this first value, 1/3, all squared. I've got a plus sign, and then this is also a perfect square trinomial, so I can factor it as y plus 1/3 squared equals, they all already have the same denominator, so 23, 24, 25/9. And I can tell when it's in this form that my center is at 1/3, negative 1/3, and my radius is, don't forget the square root, so 5/3. All right, so if I'm graphing that up here, one thing I could do again is change this scale to go by thirds if I want to, if I think this is going to be too bunched up. I'm going to go ahead and do it with using the 1/3, but then if it looks too bunched up, maybe we'll go back and change that scale and see how we could do that. So I've got a center at 1/3 and negative 1/3 right here. Okay, and then if my radius is 5/3, think about this. I am going towards the right. If I'm over 1/3, here's 2/3, plus 3 more thirds is 5/3, right? I'm just below this 1/3. So now this is 1 and 1/3. Remember 5/3 is 1 and 2/3. So 1/3 above there. Again, I'm just 1/3 to the right. So 1 and 1/3, I need 1/3 more. But I'm 2/3 to the next grid line. So 1 and 2/3 would hit me right on that grid line. And then just connect my dots with the circle. Now, be careful. Sorry for marking it out. I meant to underline it. Be careful. If the constant on the right-hand side, after you perform your completing the square steps, is not positive, it does not represent a circle. If the constant is 0, it will be the graph of the single point HK. In other words, after you complete the square and you wind up with, let's say, x minus 5 squared plus y plus 2 squared equals 0, this means it's got a radius of 0, right? A circle with a radius of 0 isn't a circle. However, I can just graph this point, 5, negative 2, right? So if you wind up with a 0 on the right-hand side of your equation, 5, negative 2, the point there is what your graph looks like. If you wind up with a negative on the right-hand side of your equation, there is no graph that exists for this equation. Don't say it's the point or, a center with a radius of, what would that be if I took the square root of it, an imaginary number. Oh, an imaginary radius? No graph exists. So be aware of that, right? You have to have a positive value for your radius. If you get a 0, it's just a point. If you get a negative value, no graph exists. Okay, any questions on circles? Just let me know.